Last lesson we learned about inverse functions, and this is really similar to what we're doing today. Remember that if we have a one-to-one relation, then the original graph is a function, and the inverse is also a function. It's the only one where both the original and the inverse are both functions. If it's a function, you know that we can call it f of x equals whatever the equation is. And we have some other notation for inverse function. We call it f with a little minus 1 up there of x, and that represents that we've found an inverse function. Now there's some cool little properties. If you find the inverse function, f of minus 1 of x, if you sub the original function into the inverse function, you should always get x, that line of symmetry that goes between those two functions. If you do it the other way around, you should also get the same thing. If you sub the inverse function into the original function, you will also get x. A reminder in the box below that if you are wanting to find an inverse function, if there is an f of x in the question, we're going to replace it with a y because we don't want to have the f of x in there when we're doing our rearranging. Reverse the roles of x and y. That means the y's become x's, the x's become y's. Solve for y in terms of x. That means get the y by itself. But for your final answer, you need to put the y back to be f of minus 1 of x. Okay? So, question number 1. Move screen. There we go. Find the inverse function for each equation that I'm giving you here, and then we're going to sub the original function into the inverse function to show that we get x. And we're going to do it both ways. We're going to sub the inverse function into the original function and show that we get x as well. But first of all, let's find the inverse. So the first thing we need to do is, instead of f of x equals, we're going to write it as good old-fashioned y equals x cubed plus 5. Then we can do our switch. The y becomes an x, so it's x equals, and the x becomes a y cubed plus 5. Then we just want to rearrange the equation to get the y by itself. So that would be y cubed equals, subtract the 5, x take away 5, and then get rid of the power of 3 by doing a cubed root. Okay, that is the answer, but we have to put it back into the function notation. So we want to say inverse function of x is equal to the cubed root of x take away 5. Okay, we did that last lesson just without the function notation part. So now the second part of the question, where we want to sub them into each other. So I'm going to start with subbing the original function into the inverse function. I'm going to go inverse function, subbing in the original function. What do we get? Well, my inverse function is the cubed root one. Cubed root of x minus 5. But the x minus 5 is the x cubed plus 5, which is the y from the original function. So my f of x is equal to the x cubed plus 5, right? I don't want to put just y in there. I have to put what my original function is equal to, the x squared plus 5. Does that make sense? So, and then I have a minus 5 after that. Now, I don't actually need those brackets there. I was just putting them in there to show you that that part is the f of x that I'm subbing in. But I do have a plus 5 and a minus 5 that are going to cancel out there. And then I have a cubed root of x cubed. What does that make? Just x, as expected. Okay, let's show the other one. Also, if I take the original function, f, and I'm going to sub in the inverse function this time. My original function was x cubed plus 5. Now the x cubed is going to be I have to replace the x cubed with the other function, which is the cubed root of x minus 5. And I have to cube it, so that's my x cubed, right? Plus 5. Now again, I'm cubing a cube root, so they're going to disappear, and I'm just going to have x minus 5 from that first bracket, and then the plus 5 on the end. And again, the minus 5 plus 5 cancels out to give an x. So either way I sub them in, I do get the x that we were expecting. Let's try for the second one. F of x equals 2 square root of x minus 1. So first of all, we rewrite the equation with a y. Then we do our switch. X becomes y and y becomes x. Then we want to get y by itself. So I'm going to keep the 2 square root y, and I'm going to add the 1 across to the other side. Then I'm going to divide by the 2. So all over 2. And then to get rid of a square root, I have to square both sides. So that would be y equals, to square that fraction, I want to square the top, which would be x plus 1 all squared, and square the bottom, which would be a 4. You could expand out the bracket on the top if you wanted to, but I'm just going to leave it like that because it will make it easier. So the final thing to do is to write that back in function notation. So inverse function of x is equal to x plus 1 squared over 4. So let's just show, we'll just do it one more time. We won't do both of them this time. I'm going to show that if I sub into my inverse function, the original function. So my inverse function is the x plus 1 in brackets squared over 4. So the x in there is going to become my original function, which was the 2 root x minus 1. So that is 2 root x minus 1. That's my x value. Then the rest of my inverse function says plus 1 all squared over 4. Does that make sense? Everyone's following that? Now in the bracket, I have a minus 1 plus 1. That's good news. They cancel out. And then I just need to square the 2 square root x. So I square the 2, which becomes 4. And squaring the square root means the square root disappears and it's just an x over 4. And of course the 4's will cancel out. And there's my x again. Okay, so that's a bit of fun, finding inverse functions and then just showing that lovely little property that they have. But there's some other types of questions over here on the next page. Restricting the domain so that the inverse is a function. Now remember I said if it's a one-to-one relation, then we know the function and its inverse, they're both functions. Okay, but remember our many-to-one relation? That's our normal parabola, right? So the original function, the original graph is a function, but its inverse is not. But we can make the inverse a function if we restrict the domain. Okay, so if we think about it, I'll give you a little example here. We've got y is equal to 2x squared. Okay, now I'm going to draw a rough little graph over here. This is not part of the answer. I'm not doing this at all to scale or showing any turning points or values or anything, but it's a parabola, right? The 2 just makes it steeper. At the moment, vertical line test, that's a function for the parabola. The inverse, remember, is a horizontal line test, not a function. If I want to make the inverse a function, you need to find wherever the turning point is and restrict your domain to only one half, either going to the left or going to the right. So I prefer to keep my x values positive, just they're nicer. So I would choose to go, here's my turning point here, and I'm going to restrict my domain so that I'm only looking at that part of my parabola. Okay, because that means it'll pass the horizontal line test. I'm getting rid of the other half of that parabola, right? So I'm going to say let f of x, so I'm making it a function, is equal to 2x squared when x is greater than or equal to 0, because that's where my turning point was. Now, it is going to make your life easier, knowing that we're going to an inverse function here, if you also find the range here. Because remember, domain and range of the original, you just flip them for the domain and range of the inverse function. So what is the range of that function currently? Y must be greater than 0 as well. Yes, correct. Okay, so there it is. I've taken my original graph, I've restricted the domain and range so that now both my function and both my graph and its inverse will be functions. So now I'm going to actually find my inverse. So I'm going to say, then, remember that's a y equals, I'm going to do a switch. So it's going to become x equals 2y squared. I'm just switching my letters straight away. And I'll get my y by itself, so I'll divide by 2. That's x over 2. And then I will square root, which remember does mean that it could be a plus or a minus. Technically there. However, usually you will find one of them works and one of them doesn't. Okay, remember, what is my domain and range of this going to be?
Greater than 0.
X has to be greater than 0, and because they were the same, both y equals greater than 0. I switched them, but they're still the same. So if I have my little plus or minus sign there, knowing that x has to be greater than 0 and y has to be greater than 0, are both the plus or minuses possible? Which one's not possible? The minus, correct. So I can just go, I actually can't have, even though I know when I square root stuff, it should be a minus sign in there. The negative will not work given my domain and range. So that would be my answer there. I should write it in my function form. So I'll go inverse f of x equals the positive square root of x over 2 when x is greater than 0 and when y is greater than 0. Yeah? Let's do another one like that. The next one's very similar. Yeah, that's it. We're just trying to restrict. The question was restrict the domain and find the inverse function defined over that domain. That's all we're doing. Yeah. So let's do it again. And so the same thing again. It says by restricting the domain of this new equation here, find the inverse function defined over that domain. So same question exactly, except for a different equation to use, doing the same process. So this is still a parabola. Okay, you look at that equation, you can identify that's a parabola. A little bit harder than the last one because my vertex has been moved off the origin. I need to know where that is, okay, because you know you've got to split that parabola in half so that you can make the inverse a function, okay? So first thing you would do is to factorize that parabola so you know where the zeros are. So I'm going to factorize the x out, which would give me 4 take away x inside the bracket. The minus x squared there does tell you that that parabola is concave down. And the zeros I can now read off from my factorized form there would be at x equals 0 and x equals 4. So quick little sketch, even if it's not giving you any marks, it's still going to help you visualize what's going on. I have 0 and I have 4. I know it's concave down.
Would it be negative 4?
No, because it's 4 minus x. You'd move the x across to make it positive to the other side. Yeah.
2.
So the turning point, yes, will be at 2, right in the middle. Now, because I want a domain and a range, I'm going to need to know the height of that vertex. So you sub x equals 2 into your equation. So you go 4 times, I'll put it into the original one, 4 times 2 minus 2 squared.
Is there ever a parabola where the turning point is slightly off
4?
center?
No, those are all symmetrical. So is it 4 correct? So there it is, turning point. My parabola is coming down like that. Okay, so I've now found the vertex, which is important, is at 2, 4. So I'm going to restrict my domain and range. So we're going to split the parabola down the middle at that turning point, at the vertex there. So that's when x equals 2. Remember, I like to take the positive side. If you do it with the values going towards the negative, it's still okay. It's still going to be a function. But I just like positive numbers better. Okay, so we're going to have x is, oops, not the highlighter, x is greater than or equal to 2. What is my range? Very good. Okay, so from that turning point down for the y values. Okay, so now let's find our inverse. This one's a little bit more exciting. This is a good one, this one. All right, let's find the inverse. I know, you should. Got to get excited about that. Okay, we are switching the x's and the y's. So we're going to have x equals 4y minus y squared. And this is why it's exciting. Look at those y's. We need to get y by itself, and at the moment that is looking rather like a quadratic. So we have to do a completing the square. Exciting. Okay, so first of all, I'm going to make the y squared positive. Okay, I'm not going to do a completing square with a negative y squared. So let's move that to the left-hand side. Positive y squared, and then bring the 4y over, so it'll be negative 4y. Which means I'm moving the x to the other side because I don't want it with my y's. So negative x on the other side. Just completely switching sides for both of them. So the y squared minus 4y, making a perfect square, you take those first two terms and the minus 4 you halve and square. Half of minus 4 is minus 2 and minus 2 squared is 4. And you add 4 to both sides of that equation. That means that we can factorize our perfect square to be y minus 2 all squared equals minus x plus 4. Okay, then, remember I'm trying to get the y by itself, so I have to get rid of that squared, which means I will square root. So y minus 2 is equal to the square root of minus x plus 4, and depending on what the value of x is, tells me whether that is going to be possible or not. And remember, that could be plus or minus because I've square rooted something. I'm going to have to work out which one is the one that actually works for my domain and range. Then finally, I'm going to have to add my 2 across to the other side. So plus or minus square root of minus x plus 4 plus the little 2 on the end. So let's have a look. We know, I'm going to put it over here, my domain and range. What's my domain going to be for this graph? Oh, I'm writing it down before I've asked the question. Yeah. So remember up here, my domain and my range. My range was y is less than 4, which means for my inverse, my x is going to be less than or equal to 4. They switch. And my range is going to become what the domain was, which is y is greater than or equal to 2. So have a look back at our equation, which one is going to work. So if I choose an x value that's greater than 4,
It has to be less.
if I choose an x value that is greater than, less than 4, not greater than 4, it says less than 4. So like 3. Minus 3 plus 4 is 1. Square root of 1 is 1. Plus 2 is 3. Is 3 greater than 2? Correct, that fits. If I had the minus sign in there, I would have had minus 1 plus 2, which is 1, and 1 is not greater than 2. So that didn't work if I used the minus version of that formula there. Yeah, do you see what I'm doing? I'm subbing in an x value for the domain that I know has to work to see whether the positive sign or the negative sign is going to put me in the right range.
Minus 5, right?
Did I minus 5?
Yeah, because minus 5 minus x, that makes it positive.
Minus
4 plus 5 equals 9 plus, which then equals 3 plus 2, which equals 5, and 5 is greater than 2. You just broke it.
You broke it? Anyway, let me finish this and I'll think about what you just said again.
Why can't you sub in 0?
You can for x.
Yeah.
Okay, so 0 plus 4 is 4. Square root of 4 is 2. Now we need to know whether it's going to be a plus 2 or a minus 2, right? If it's a plus 2 plus 2, that makes 4, and 4 is greater than 2 over here for my range, so that works. But if I went minus 2 plus 2, I get 0, and 0 is not greater than 2 for the range, so that one doesn't work. So both values that I have subbed in, I'm not sure which one Ben was trying to do, Isaac, sorry, was trying to do a second ago, but both the ones I've subbed in work if I take the positive version of that equation. Okay, so I'll stop the video and then you can tell me again what it was that you were